Everyone, this is Mr. TEY speaking, and in this video I'll be going over dot product of vectors, cross product of vectors, and its application. So first of all, on topic 1, what is dot product? Dot product can be simply defined as the multiplication of two vectors for which the result is a scalar quantity. And for this reason, it is also known as the scalar product. So take this figure for example. Here we are given two vectors, AC and AB. And to find the dot product between the two vectors, we can simply take the magnitude of AC times the magnitude of AB times the cosine of the angle between them. And this equation can be used in both R2 and R3. So depending on the variables given in the question, we can use this equation to look for obviously the dot product, or we can look for the magnitude of each of the vectors, the angle between them. But most importantly, in the real world, we can use dot product equation to look for the work done. So let's move on to the first example. Vector A has a magnitude of 2 and vector B has a magnitude of 4. The angle between A and B is 30. Determine the dot product. So this question is very simple because the question has already given us all of the values that we need. We simply need to sub it into this equation directly. So the dot product of A and B equals to the magnitude of vector A, the magnitude of vector B, and the cosine of the angle between them. And plug this into the calculator, and the answer that we will be getting is about 6.93. So let's move on to the second example. So there is actually another way to find the dot product between two vectors, but this is only valid when the coordinates are directly given. So take this question for example. Vector A has the coordinates of 1, 2, and 3, and vector B has a coordinate of -2, 3, and 1. So to find the dot product, we have to first list it out like this: 1, 2, and 3, -2, 3, and 1. And we simply have to take the multiplication between the two x value, -2, plus the multiplication of the two y value, 6, and plus again the multiplication of the two z value, which is 3. And the final answer that we'll be getting is 7, which is the scalar quantity, which is the same as the one you get here. So moving on to the third question. So this question explores a phenomenon that is worth taking note of. Which is when two vectors are perpendicular to each other, meaning that the angles between the two vectors is 90 degrees. So using this question, vector A has a magnitude of 5 and vector B has a magnitude of 2. So the two vectors are perpendicular to each other. Determine the dot product. So using the equation that we had used before, A times B equals to magnitude of 5, magnitude of 2, and the cosine of the angle between them. And in this case, it's 90 degrees. And when you plug it into the calculator, the cosine of 90 equals to 0. So whatever the magnitude is, the dot product will always be 0 when the two vectors are perpendicular to each other. And this could be very useful in questions that you may encounter in the homework section. So here are some of the properties of dot product. So the first one, commutative property, which states that the vector P times vector Q is the same as vector Q times vector P. And this is because the result is a scalar quantity, as it does not involve the direction at all. So the second one, distributive property, which states that vector P times bracket vector Q plus vector R is the same as vector P times Q plus vector P times vector R. So the third one, which is quite important, is the magnitudes property. So it states that when between the dot product of two same vectors, the result will be the magnitude of the vectors squared. So to illustrate this, we know that using the equation before, the dot product of these two vectors are magnitude of p times magnitude of p and cosine. And since the two vectors are the same, the angle between them will be 0. So it will be cosine of 0. And when plug into the calculator, cosine of 0 equals to 1. So here, the dot product would be simply the multiplication between the two same magnitude, which results in magnitude of p squared. So the fourth one is the associative property with scalar k. So which states that when a scalar quantity is involved, no matter where you put it, the final answer will still be the same because it is a scalar quantity. And the results that we are getting by the end of the dot products is also scalar. So it doesn't really matter where you put it. So last but not least, the dot product equation can be used to find the work done that we often encounter in physics classes. So take this question for example. Tobin is pulling her daughter in a toboggan and is exerting a force of 20 Newton, acting at 30 degrees to the ground. If Tobin pulls the child a distance of 80 meters, how much work was done? So when a constant force is applied to an object so that it moves from a straight line from point A to point B, the work done by the force acting at an angle from the line of motion is a dot product of the force vector and the displacement vector. So here we ended up with a figure similar to the one that we had explored above. So to find the work done, we can simply use the dot product of this figure. So for example, work equals to the magnitude of force vector, which is 20 Newton, times the magnitude of displacement vector A to B, which is 80 meter, and the cosine of the angle between them, which is 30. And it is to note that the SI unit for force is in Newton and for displacement is in meter. And the final answer that we'll be getting is about 1385.6 joules. And this equation is essentially equal to the equation that we often use in physics class to find work, which is the force vector times the vector of displacement. So moving on to the second topic, which is the cross product of vectors and its application. So what is a cross product? Cross product can simply be defined as the multiplication of two vectors for which the result is a vector quantity instead of a scalar quantity. And the vector that we found is perpendicular to the two given vectors. So this can only be used in R3, and the properties of cross product is actually very similar to the property of dot product, except that it is not commutative, meaning that P cross Q is not the same as Q cross P. And this is a concept that we will be discussing in later questions. So As for its application, it can be used to find several things, which includes the area of triangle or parallelogram when two of its vectors are given, as well as the magnitude of torque that we so often encounter in physics classes. So let's move on to the first example question. So given vector A 2, 2, 0 and vector B 2, 4, negative 2, determine the cross product between vector A and vector B. So the formula for cross product is as follows. So the first thing that you have to do is to put it like this, equals to positive. So in the first step, you overlook the first row. So you get the multiplication of this two, negative 4, minus the multiplication of this two, which is 0. And on the second step, you do the same thing. But instead, this time it's a minus, and you are overlooking the second row. So it'll be the multiplication of this 2 minus the multiplication of this 2. So what you get is 2 times negative 2, you get negative 4, 0, and minus 0 times 2, you get 0. And on the third step, it's the same thing. But this time, you are overlooking the third step. So you take the multiplication of this minus the multiplication of this. So what you will be getting is two times 4, you get 8, and 2 times 2, you get 4. So the final answer would be negative 4, 4, and 4. And this is the vector that is perpendicular to vector A and vector B. This one. So moving on to the second example. If the vectors above are vectors of a parallelogram, determine its area. To determine an area of parallelogram with given vectors, we can simply find the cross product between the two vectors and then turn it into the magnitude of the vector. So using this as an example, the answer would be negative 4, 4, 4, and the magnitude equation would involve the square root of negative 4 square plus 4 square plus 4 square, which gives us square root of 48 unit square. And to determine the area if the vectors given above were a triangle, remember that the parallelogram, you divide it by half and it is a triangle. So the area of the triangle would simply be the half of the area of the parallelogram. So you have to do the steps above, but since we've already done it, all we have to do now is to take 1/2 of square root 48, which equals to square root of 48 divided by 2, and the answer that we'll be getting when plugged into the calculator is approximately 3.46 unit square. Very simple. So moving on to the fourth question. With the previous vectors, determines vector B cross vector A. And what do you notice about the answer? So vector A was 2, 2, 0 and vector B was 2, 4, negative 2. So this time it will be 2, 4, negative 2 times 2, 2, 0. And it will be equals to the same thing as we did before. You overlook the first row. 0 times 4, you get 0. 2 times negative 2, you get negative 4. Minus negative 4, you get positive 4. Minus overlooking the second row, 2 times 0, you get 0. And 2 times -2, you get -4. And minus -4, you get +4. And last but not least, you overlook the third row, and 2 times 2 equals to 4, and 2 times 4 equals to 8, so -8. And the answer you'll be getting is 4, -4, -4. And this is the vector for B times A. So if you bring this down, what you will notice is that these two vectors are opposite, meaning that, for example, this is vector A and this is vector B. A times B will be this one, and B times A will be this one. And as a result, it can be concluded that vector A times B is not the same as vector B times A, and therefore they are not commutative as explored in the properties here above. And moving on to the last application, which is to find the magnitude of the torque. So take this question for example. A 20 Newton force is applied at the end of a wrench that is 50 centimeter in length. The force is applied at an angle of 60 degrees to the wrench. Calculate the magnitude of the torque about the point of rotation M. So by looking at the figures here, an equation that we can derive of is this one. So to apply, the magnitude of the force is the cross product between the vector of radius and the vector of force, and it will be equal to the magnitude of radius vector, which gives us 0.5, and the sine of the angle between them, which is 60 degrees, and multiply this by the magnitude of force, which is 20. And the answer that we'll be getting is approximately 8.66 joules, which is the magnitude of the torque. And this brings an end to my video explaining cross product as well as dot products along with their application. So if you have any questions, feel free to email me or comment down on the website. And that's it for today. Thank you for listening.